Good day everyone. Today we're going to discuss Java stocks. I'm Josh Lister Cabunoc and today I'm going to discuss what is Java stocks. But first, let's go to the table of contents. First, we're going to see what is Java stocks. Second, stock operations. Number 3, examples using stock class. Number 4, real-world examples. And number 5, the summary of our presentation. But first, what is Java stocks? So, Java stocks is a fundamental data structure that follows last in, first out, or the LIFO principle. This means that the last element added to the stock is the first one to be removed, much like a stack of plates where the top plate is the first one to be taken off. Stocks are widely used in various applications of programming due to their efficient way of handling data. Some common use cases for stock includes managing function calls. When a function is called, it is pushed onto the stack. Once the function completes execution, it is popped off the stack, allowing for proper program and return values.
Hi everyone, in this segment, I'll be explaining the basic operations we can perform on a stack. A stack is a last in, first out data structure, which means the last item we put in is the first item we take out. The 4 main operations on a stack are: number 1, push. This operation adds a new element to the top of the stack. Think of it like placing a new book on top of a file. Number 2, pop. This removes the top element from the stack. Continuing the book analogy, it's like taking the top book off the pile. Number 3, pick. This lets us look at the top element without removing it. We're basically just checking which book is on top. Number 4, is empty. This operation checks whether the stack is empty. It's a simple way to confirm if there are no more elements left. And that's it for stack operations. Remember, push adds, pop removes, pick inspects, and is empty check if there's nothing left. Understanding these basics will help you work with stocks in programming and data structures.
Hi, I'm Vergel Bautista, and today we'll explore Java stocks with some examples. So, as shown in the illustration of Java stock data structure, elements are stacked on top of each other. The first element added is at the bottom, while the most recent element is at the top. This follows the last in, first out principle, meaning the last item added is the first one removed. So in this case, we can use push method to add new elements to the stock, and the pop method to remove the top element. For example, if we have 4 elements in the stack, calling pop method will remove the 4th element, which was added last. Now, let's go through a simple Java program that demonstrates how stacks work. We start by importing the stack class from Java's utility package. This allows us to use stack operations like pushing, popping, and picking. Inside the main method, we create a stack that stores integer using this code. So this initializes an empty stack that we can start working with. Next, we use the push method to add elements to the stack. First, we push the number 10 and then we push 20. At this point, 20 is on the top of the stack. So, to check the top element, we use pick method, which returns 20 since it was the last number added. However, pick only retrieves the top value without removing it. Now, let's remove an element using the pop method. Since stacks follow the last in first out rule, pop removes 20, which was the most recently added element. After that, 10 is now at the top. Finally, we print the stack to check the remaining elements, and it shows 10. This confirms that 20 has been removed while 10 remains in the stack. To summarize, we created a stack, added values using push method, check the top value with pick method, remove the top element using pop method.
Now that we've covered the basics, I'll show another simple example to solidify our understanding. Let's create a stack of strings instead of integers. First, we declare a stack that stores string values. Next, we put 3 fruit names onto the stack: apple, banana, and cherry. We then print the stack to see its contents. After that, we use the pop method to remove the last inserted element, which is cherry. Finally, we print the stack again to see the updated contents. And as you can see, when we run the code, just like that. So that's it. I hope this explanation was clear and easy to understand. Thank you for listening.
Hello everyone, I am Adrian, and today we will be talking about real-life example. Memory management. Stack store function calls local variables, adding a frame for each call and removing it when done. This ensures efficiency memory use. Parsing expression. Compiler use stack to evaluate and parse expression, handling operators and operands in the correct order. Reversing string. Stack reversing sequence by pushing and popping elements, ensuring accurate backward processing. Syntax checking. Stack checking balance parentheses and other symbols, ensuring correct expression structure.
Hi, I'm Martin Camata. Here's a summary of our discussion. A stack follows the LIFO principle, which stands for last in, first out. This means that the last item added to the stack is the first one to be removed. In Java, stacks can be implemented using the stack class or a linked list. Both provides efficient ways to manage data using push, pop, and pick operations. Java stacks is useful for managing memory, recursion, backtracking, and expression evaluation. Because of its efficiency and versatility, stacks are an essential part of system design and software development. Understanding them is crucial for writing optimized code and solving complex problems. That's a quick overview of Java stacks. Thank you for watching.